Hey guys, how's it going? Welcome back. Well, today I want to talk to you about my ideas and theories behind the expanding universe and black holes and what I think actually happens. So, I don't believe that the universe is actually expanding at all. At least not our known universe that we can actually view. And that's just the ticket. Even our best, most powerful telescopes we have, whether it be on planet or off planet, they can't see the entire universe. Okay, there's no way we have that kind of technology available to us. So we see a portion of it. So we really have no idea, realistically, the size or the shape of the actual whole universe that we happen to be in. Okay, so. And at the same time, it's also the expansion of the universe. If we can't see the entire thing or know its boundaries or borders, how can we say that it's really expanding? I don't really believe it is expanding. I think that there's a lot of stuff in our universe that disappears all the time into, like, say, black holes, or a planet may explode. It doesn't have to go into a black hole to have more room to be made. And what happens is, our entire universe and all the galaxies and planets and everything else, they all have the gravitational pull of each other that they have to deal with all the time, and it's very finite. And when you disrupt that balance, what it does is it can create chaos. And so the universe has to adjust all over with everything and recalibrate everything so that things stay balanced. Otherwise, and it has to do it rather quickly too, so that there's not a huge noticeable change, right? The biggest change that would be noticed would be planets nearby where, say, a planet or a star disappeared from, or got sucked into a black hole, for example. Those areas would be more affected drastically than, say, us, because we're like, we could be millions or billions of light years away, from where that item had disappeared, be it an explosion, supernova, black hole. So the universe really doesn't expand. It shifts and moves things as it needs to. So when a scientist says, 10 years ago, this star was over here and it was about 10 light years away from us. Well, now it's, 13 light years away, or it moved a whole light year, or a half a light year away. Whatever distance it moved, it appears that is different. Well, a couple of things actually affect that distance that maybe they're not even thinking of. So let's look at how we orbit around the sun, and sometimes we're closer to the sun, sometimes we're further away. So depending on when you're observing these stars or galaxies or planets, maybe on one portion of the year it's going to be further away, but another portion of the year, if you're looking at that same time but when we're closer, then it is actually closer to us. So maybe when you first took that reading, the guy who took it, so okay, right now it's it's like 10 light years away right now, and then come winter time, 4 or 5 months down the road, we're in another portion to the sun and we're moving further away. Now it's moved further away, and it's like, and the distance we are from the sun is actually pretty far away, and we still get a considerable amount of heat from the solar radiation and stuff that warms up our planet. And it's part of the cycle of warming it up. It's not just us moving through space either. So there's a distance factor there. So right now, we got this pen. We're going to call this the sun, and we're going to call this torch the earth. Now, let's just say, for example, because I have no idea to be honest, but say right now we're this far from the sun. Well, we come around to springtime, because we follow an elliptical orbit. Now, in say June, we're over here. Now that's almost twice the distance, 3 times the distance away. So if you were looking at a particular star that you said, well, right now that star is, it appears that it's really far away. Well, now you're over here, it's even farther away. Okay, or here it was closer, now here it's further away, or now here it's closer and here it was further away. They a lot of them assume it's an expansion of the universe. It's not. We follow an elliptical orbit, so at certain times of the year, things will appear closer to us, some things will appear further away, and that changes, all the time for that. Where things are actually, in reality, really are moving further away is when things start getting sucked into black holes, planets and stars are going supernovas, or just getting plain obliterated, that sort of thing. And it could be, 100,000 light years away that this happens, and maybe it takes 10 years for us to notice the difference, but there's a difference that gets noticed, right? And things appear to be separating out more. And that's because the universe needs to rebalance itself every time something like this happens. And so it's in a constant state of movement, of shifting and moving stuff as things go, So, but the scientists are assuming that the universe is expanding in that aspect. And I don't see that as being an expansion. I see that as a recalibration that has to be done. Otherwise, if it wasn't done, then there would be total chaos through the whole universe, and things would really start going nasty, right? So in our case, right now, say our closest point to the sun is here, at any given time. Well, if things don't change, and for the better, to rebalance, and things go out of balance, we could end up here, in which case we're done, or we could end up further out here, in which case we're definitely done, because now we're going to be a really super, super cold planet, because normally we need to be this far away or this far away, or even this far away, to balance out our seasons. If we start going in closer, we're going to have a lot of heat issues. We're not going to have a proper balance. We may never see winter again. So the universe needs to constantly recalibrate and change those distances accordingly. Now they are finite, so there's not a real massive change that we're noticing, but there is a change that we notice. But there's also the normal change too, of being from here in the middle of the winter or in the summertime to being more out here in the winter or spring, or wherever you want to put this organizational distance thing around. So other planets, other solar systems, other galaxies, they're going to have all their differences, and and the universe has to keep things in constant balance and check. So is our universe really expanding? No, I don't think it really is. Now, what happens to planets that get sucked into black holes? Because planets get sucked in, stars get sucked in, debris gets sucked in, all kinds of stuff. Where does that stuff actually go? Well, there's some theories behind that. Now, a black hole, all we see is basically a big circle, right, type of thing. And we see, stuff surrounding it and being sucked in. We don't see any stars. We see nothingness. We see total blank. No stars, no nothing in the middle of a black hole. That's why they call it black hole. Now, what's on the other side of that black hole? Well, on the other side of that black hole could actually be new galaxies and planets forming, especially from the debris and stuff, right? Because if our galaxies and that are formed from debris and stuff mashing together and all that sort of stuff, then I would say that's probably what's going on the other side of this black hole, and that there's definitely, there's enough room on that other black hole. There's a whole new universe there, which is now getting stuff fed into it. And part of that universe, it'll also have black holes, that will also penetrate into another area, which could be another universe, and another universe, another universe, which makes the multiverse theory very acceptable. That it's a reality. Would a black hole go into, say, another dimension? Well, I don't think so. I don't think it would be another dimension. I would think it would be a portal to another universe, perhaps, but not another dimension per se. When you start talking dimensions, you're in a whole other area altogether. But when it comes to the possibility of that black hole actually leading to another universe, yeah, I can see that being a good sound theory that would probably be not very hard actually to prove. The easiest way to prove it would be to find a way to get some sort of a craft, be it manned or unmanned, with the capability of recording, and also a craft that can withstand the gravitational pull and forces and any kind of compression against that craft so that it would make it through the black hole without any difficulty and to the other side. Now, what's on the other side, that's what we need to find out. If it is another universe, kudos, our ideas are correct. If it's total nothingness, well, obviously we were wrong. You know, if we can't make the trip and something happens and we get crushed, well, we got to try again and go with even stronger craft in order to make it through. So when you start looking at a lot of this stuff, you know, we have a lot of great ideas, and physicists have a lot of great ideas, especially theoretical physicists, you know, because a lot of their stuff is based on theories and ideas that seem to be plausible. And some of them are very, you know, easy to believe too, because they make so much good sense. But that doesn't make it correct either, you know. And when I watch videos myself on, you know, the expanding universe, the universe is expanding. No, it's not expanding. The universe is not expanding. You have no way of telling that the universe is expanding. Your idea of it expanding is simple. Stuff goes into black holes. The universe has to shift around, make room. Yeah, some things get further away, other things will get closer away. The fact that we follow an elliptical orbit as it is around the sun also changes our perspective from season to season of how far or how close something actually is. So now let's go and explore the idea of right now. Okay, let's say this is our sun. Let me just actually start this over on a new fresh slide. Okay, our sun's going to be in the middle. Okay, let's go with the whole 9-planet theory, okay? So, let's say right now, we're at our furthest point from the sun, because it's bloody cold down here right now, at least on this side of the planet. And of course on another side of the planet it's actually closer to the sun. Okay? So, now on this side of the sun, that's us right now where I'm living, okay, in Canada. Now these guys on the other side of the world, they're closer to the sun, so they get their summertime right now. So, if you start looking at stars and other, you know, let's just say for stars for sure anyway. It's not like I can draw an entire galaxy on the paper. Okay, so right now, let's say this closest star to us, no matter which side of the planet you want to go on, because there's not much of a change here, let's say it's 10 light years away. And so as we go around the sun, okay, Earth starts out here, further away. Now let's say this is Earth over here in the summertime for us, so we're much closer to the sun. Now we're going to look at that one main star that was 10 light years away. Maybe now it's 12 light years away, okay? Because we've now not only come off around the other side of the sun, but now our perspective has also changed. So instead of going at an angle from here to here, now we're from here to here. We're much further away from that star. So that would give the impression that the universe is expanding, okay? It's now, that same star is now much further away. And now, let's say we have a planet that explodes in our just in our own galaxy, period, okay? Just within our own galaxy. Now this is our solar system with our nine planets around the sun, okay? But let's say over here in this other galaxy, and of course it has the sun, and then, you know, maybe it's got, you know, 15 or 20 planets around it, type of thing. Let's say one of those planets goes away. Okay, now everything, once this planet disappears over here, all this stuff has to recalibrate, and its distances are going to change, and they may have to spread out little bits in order to compensate for that missing planet now, still keeping the same distance from each other, and, you know, orbits around the sun and everything else, right? Plus, don't forget there's moons and everything else to consider. And if this planet had like, say, 3 moons, and it took a moon or 2 out with it and only left 1 moon, well, now that really makes a mess of stuff. So now things really got to change over here, right? And this is still our own galaxy, right? So now our planet is going to be different. Now our seasons are going to be really out of whack, you know, until something else can be realigned, or something else has to happen in order to, you know, get things kind of back on track. You know, I mean, you've noticed yourselves, I'm sure, they talk about the greenhouse effect and stuff, right? And that's kind of an annoying thing, but, you know, among other problems on Earth and different weather patterns that have, you know, we're starting to get much colder right now. I mean, last winter it was actually pretty cold. The winter before that was actually kind of mild. So, you know, within a couple of years, things changed, right? So what's changing out in the universe, what's changing out in the galaxy that could be causing little minor shifts that would alter us? Because everything that happens out there, even in our own galaxy and other galaxies, affects us here, right? So, but the whole distance thing changes. Now, the next time we come around the sun here to our next cycle where we're further away, you know, and let's say this is our winter time, right? So now we're further away again. Now, is that 10 light years still going to be a 10 light year distance, or is that now going to be, say, 11 light years because it had to move? Or maybe it's 10.1 light years away, or 10.05 light years away. It changed, period. There's a noticeable difference. What happened? Something happened in our galaxy. Something happened in another galaxy or another part of the universe, and things shifted and changed to keep the natural balance of things so that everything stays on a proper key, right? It's kind of like if you play a guitar. Now, I'm a guitar player myself. If one string is just slightly out, it throws the whole mess out. It causes total chaos. So the whole sort of thing applies to this. So when black holes and stuff are involved and things get sucked into them, and, you know, everything has to change and recalibrate and retune so that it stays in proper sync. And I think that's more realistic of what's happening than a so-called or apparent expanding universe that we don't really even have a clue how large this universe is, or if there's an end to it, or if there's even an actual shape to it. I personally would like to believe myself that there is no actual size that could ever be measured, or shape either, because that would put us into a box. And the box theory would be kind of like Christianity. They believe that, you know, most Christianity stuff anyways, not all of them, but most, believe that we're it. All there is us on this planet and the entire universe. Even though God created all this stuff, we're it. We're the only life forms out here, and that's all there is to it, and blah, blah, blah. And that the universe is just so big, and that's it, and, you know. But on the other hand, they kind of do believe in an infinite universe, because when they say that God throws your sins as far as the east is from the west and it can't come around, that's the same as the universe. It's infinite, right? So I do believe in an infinite universe myself, and I believe that there is no actual particular shape that we can figure out from there, you know. But you think about it, there's billions of planets in our own galaxy alone, and there's billions of galaxies, right? And so, and in each one of those galaxies also contains billions of planets, okay? And there's, of course, multiple suns too, because there's X amount of solar systems per galaxy, right? So each solar system has to have at least one sun for sure. They could have 2 or 3 suns in their solar system. That's possible too, you know. So, you know, this creates an extreme high probability, like 100% probability. There is definitely more life out there besides us that's intelligent. And a lot of them are traveling intergalactic. Some are just getting around their own galaxy. Some are just getting around their own solar system. Like we're trying to get around our solar system right now as it is, you know, and we've been to the moon. Now we're going to try for Mars, you know, and we also assume that there's no life on these planets either, and that's a whole nother video, and which I'll actually do for you guys because I have some really good ideas on that. But that's where I stand on the expanding universe and black holes. So anyways, you know, if you guys got ideas, you know, feel free to leave your comments, and you know, let's talk about it, you know, back and forth. So we'll catch you in the next video.